Let us look at the question 12, which is on transformers. So we'll try to explain the concept of transformers using the question. So figure 12.1 represents a transformer with a primary coil which has 400 turns and a secondary coil with 200 turns. So this is structure of a coil. Now the structure of a transformer. So we need to understand one aspect here. Let's try to look at the concept of transformer in this way. So a transformer, by definition, you know that a transformer is an electrical device which changes the voltage of an alternating current. So that's a transformer. Now this transformer operates at what we call mutual induction. So we are saying it operates under mutual induction. The operation of under mutual induction, looking at the concept of magnetism and electricity. So we know that when current passes through a conductor, it produces a magnet, and when magnet passes through a conductor or magnet, produces also electricity. So if you combine these two ideas, they're going to give us what you call electromagnetic induction. Now, since it operates under mutual induction, then we need to look at the structure of a transformer the way it is. So this is structure of a transformer. So we have two types of transformers. We have number one, we have a step up. We also have a step down transformer. So how can you know that this is a step up, this is step down transformer? So let us look at the concept of a step up. Then it will help us to understand step down. So to step up, it means to increase. So a step up transformer is a type of a transformer which has more number of turns on the secondary coil than on the primary coil. So let's look at this picture. If this is our transformer, then we want to show that this transformer is a step up transformer. So this part is called the input, which uses AC. Then the windings here, so the windings, we have the primary coil. So primary coil. Then here it is called the output, and it uses DC, direct current, alternating current. So according to this statement, we want to show that it is a step-up transformer. So for us to identify that, the number of windings or the number of turns here will explain about these two sides. So we have the secondary coil. So if you look at the number of turns here and the number of turns here are different. So the more the number of turns on the secondary coil, the more current we are going to produce. Hence, step up transformer, because a step up transformer, it is producing more current from less current. So a step up transformer is a type of a transformer which has more number of turns on the secondary part than on the primary part. So this is the ion core. So the other type of a transformer, which is called the step down transformer. The step down transformer is a type of a transformer which has more number of turns on the primary coil than on the secondary coil. So it is called a step down. So if you reduce the number of turns, it means that you're reducing the amount of voltage being produced, hence being referred to as step up or step down. So these step down transformers, these are transformers which we normally see in our areas because they reduce the number of turns from that 11 kV volts cables to 240 volts, which we use in our homes. Then from here, we need to look at the operation of a transformer. How does this transformer operate? So since we said a transformer operates under mutual induction, we are going to look at what do we mean by mutual induction. So the concept of magnetism now will come in. We need to understand that when the primary coil is connected to AC source of current, then the alternating current, as it is passing through this coil or number of turns, this current will produce what you call alternating magnetic field. So these magnetic field which are alternating, to alternate means to change. These magnetic fields that are changing forward and backward will induce its alternating magnetic voltage into the secondary coil. So alternating current passing through the primary coil will produce alternating magnetic field. Then the alternating magnetic field here now, they are going to induce what you call alternating voltage. It is this alternating voltage that will in turn induce now the current into the secondary coil, and the current now will be transmitted via the cables after being increased in terms of voltage or current. So the process, we are saying, number one, the alternating current passes through the primary coil. Number two, that alternating current which is passing through the primary coil here, it will produce alternating magnetic field. So these are alternating magnetic field. Then these alternating magnetic field now, they are going to induce alternating voltage. Then the fourth one, the alternating voltage will induce the current into the secondary coil and the current will be transmitted. That is how a transformer operates. So from there, we can look at the equations which we normally use whenever doing the calculations. So we have this, the number of turns in the secondary over number of turns in the primary is equal to voltage in the secondary over voltage in the primary is equal to current in the primary over current in the secondary. Current in the secondary. Current is the only one which is opposite to these two. So we can use this equation to summarize all the calculations here. So let's look at question 1 now. So question 1, they are saying the primary coil is connected to 240 volts alternating current. So once you see alternating current, just know that you're talking about the primary coil. Calculate the secondary voltage. Now look at the numbers which we have. So the transformer with a primary coil of 400. So primary has 400, secondary has 200. So since we have, before even we use this one, since we have 400 to 200, so the ratio here is 2 to 1, meaning the ratio which are going to produce here for voltage the ratio for voltage will also be 2 to 1. So what are we saying? If we reduce the number of, look at this transformer, we can able to see that it is a step down transformer because the number of turns on the secondary coil are less than the number of turns on the primary coil. So this one is called a step down transformer. So as we are stepping down, how much voltage are we reducing? So if you have 240, then the ratio is 2 to 1, meaning this, since 200 into 400 is 2, if you do mathematics, if 200 into 400 is 2, then this 2 into 240 will give us 120 volts. So this is the answer, 120 volts. So let's prove this idea by looking at the equation. So we can predict these. These are not very much difficult. So let's put the values there. So secondary coil, number of turns on the secondary, we have 200. Then the number of turns on the primary, we have 400. Then the voltage on the primary, we have 240. So voltage secondary, don't know. Then I'm going to put 240 there. And I'm going to cross multiply. So we'll say, we can cancel this if you want. So 2 times 240, so 2 times 4, it is 2 times 0, we're going to get 0. Then 2 times 4, we're going to get 8. Then 2 times 2, we're going to get 4. Then this by this, 4 by v, we're going to get 4v, so which is equal to 4 there. So what are we getting? Our v is equal to what? So 4 into 4, it's 1. 4 into 8, it's 2. 4 into 0, it's 0. So the answer is 240, is 120. So you can predict either by looking at the number of turns, the ratio of number of turns will give you the answer very fast to the voltage. So it was reduced by 240, it was reduced by 120 watts. Then explain carefully how a transformer operates. So this is what I explained earlier on. To look at number 1, I said the primary coil is connected to alternating current. Then number 2, alternating current passes through a coil, and produces alternating magnetic field. Then alternating field. All right, so the alternating magnetic field will induces alternating voltage. Then alternating voltage induces current in the secondary coil. So this is how a transformer operates. All right, so from here, I'm just writing the abbreviations, but you can write in forward to make your own notes. So that one is done. Then question C, we're looking at why is soft iron used for the core instead of steel? 2 marks. So we're saying that if you look at the concept of magnetism, when you're comparing iron and steel, the reason why we use soft iron core instead of steel, it is because we are saying soft ion is easily magnetized, unlike steel. So soft ion core is easily magnetized, unlike steel, meaning that, all right, so the soft ion is easily magnetized, unlike steel. So meaning, if the small amount of current passes through this ion core will become magnetized very easily and produces what you call now the alternating magnetic field, which will in turn induced on the secondary coil. Then once the secondary coil is induced by the alternating magnetic field, it is this alternating magnetic field now that will create alternating voltage. Then after alternating voltage has been induced in this coil, then the same alternating voltage will cause the current to be produced on the secondary coil. Then the current will be transmitted via cable lines. So that is the reason why the soft iron core is easily is used mostly in transformers, unlike steel. Steel is not easily magnetized, in the sense that steel takes time for it to produce magnetic field lines. Again, it takes time to be demagnetized. So that is the reason why they prefer iron compared to steel. The last question is saying, if the current in the primary coil is 3 amps, calculate the current in the secondary coil of the transformer, assuming that the transformer is 100% efficient. Now we need to understand that there is no machine can be 100% efficient. So this is the reason why we are saying it is assuming, we are just assuming that it is 100% efficient. So from this, to find the current in the secondary, we can say number of turns secondary primary is equal to current primary over current secondary. So here we can get the same values. So 200 over 400 is equal to, then what do we have? We have the current. If the current in the primary coil is 3, so we're going to put 3 amps here, then over the current in the primary, we don't know, then we cross multiply. So we are saying 200 primary current is equal to 3 by 4 are going to get 120. So 12, then we get these zeros, so 1200. We divide by 200, we divide by 200, so we cancel. So our current now will be, so 200 out, then 2 into 12, it will give us 6. Okay, so now have you seen this answer which I have found here? So if you have understood this concept, you may see that this answer is wrong. So why is it wrong? Because we're talking about the current on the secondary coil of a transformer. Then you have said that if you reduce the number of turns on the secondary coil, we are reducing the voltage, at the same time reducing the current. So this answer is automatically wrong, because it has increased by 2 to the current in the primary coil, where the number of turns are many. So if you get the concept, you are able to say this answer is wrong, this answer is correct. Now what should we do now? So let's now answer a correct one. So we'll say now, I'll just use the same plates. So we'll say now we have 200 number of turns over 400 is equal to. So instead of using the current as the primary first, so we are going to say current on the secondary over current on the primary. Then from here we'll say 400 over 200 over 400 is equal to, then I'm going to do the vice versa. So we'll put current primary over 3 amps. Then if you multiply, let's cancel these zeros. So 2 by 3 to give us 6. So 2 by 3 to give us 6. Then 4 by IP are going to get a current 4. Then we divide by 4. Then we divide by 4. Then we cancel this. So once we cancel that, what are we going to get? It's so 6 we divide by 4, we're going to get, so our current now is 1.5 amps, so which is correct, because if you reduce this by half, you need also to reduce current by half. These, they go in ratios. So the overall concept of transformers I've touched. Then the only thing which has remained here is to look at the efficiency. So the efficiency formula, we know that efficiency is equal to power output. Let me write properly. So efficiency is equal to power output over power input, then multiply by 100% there. That is efficiency. So if we have power over power times 100%, that's what you call efficiency. So power output over power input. So where do you get power? So we can get power from what we have been given. Here we have voltage, we also have the current. Here also we found voltage, we have also found the current. So we know that power is equal to voltage times current. So that voltage, so this voltage now, which is here, and the current you multiply, then here and the current you multiply, then you get the values here. Whatever you're going to get will be your answer. So we'll look again into other questions, then we summarize the entire topic like that.